Hello there, welcome to APES Chapter 19 Lecture Video Part 2. Let's begin. So we finished last lecture talking about coal, so now we're going to just define some terminology you're going to start seeing. Crude oil, common term, you hear that all the time. This is unrefined oil. So part of the problem with oil is when you get crude oil, you get it out of the ground and it's full of tar and all these carcinogens and all these nasty things. That's crude oil. So when you extract it out of the ground, it does not come out like oil as you see or gas that you see in your car. It does not look like that. It looks like I said, it looks like tar. It's pretty nasty looking stuff. Okay, real thick, full of carcinogens, full of impurities. And you cannot put that stuff in your car, what comes out of the ground. Natural gas is primarily methane, hydrocarbons, carbons with hydrogens. CH4 is the chemical formula for methane. Other hydrocarbons, different gases are also found in there, but it's mainly methane, CH4. Where does natural gas happen? Well, this is like embedded within the rocks. So when these rocks get cracked or broken open, natural gas is released. That's how natural gas is extracted from the ground. Petroleum. This is this general term which refers to oil. All right. Sometimes it's oil and natural gas, but generally, most of the time, we're talking about oil. So this is what we need to put in our cars. Petroleum gets turned into gasoline, for example. Oil and natural gas, where do they come from? Well, we mentioned it earlier. Oils and natural gases are when those phytoplankton, they die, they sink to the bottom of the sea, and over time, their kerogen gets turned into basically oil or natural gas with time and heat. All right. Now, that is how most of these petroleum, for example, products, oils and natural gases are made. Oil sands, tar sands, this was part of the central case. These are really nasty mixtures of sand and clay with oil, basically. They call it bitumen, basically. It is nasty, thick petroleum. Now, for many, many, many years, nobody even tried to extract it because the energy return on your investment was so bad. It was not worth it. The amount of money you would have had to spend to extract it, it would have been too costly. You wouldn't have been able to sell it because somebody somewhere else in another country would have been producing it for much less. So it would have driven your business model into the ground. We have gotten better over time at extracting the oil and the petroleum from these rock and this oil sands. And since we're getting better at extracting it, we're basically it's becoming cheaper. And since it's becoming cheaper, it's starting to being used. The two methods. One method is the strip mining method. One is the steam extraction method. Let's talk about the steam extraction method first. You have these shafts, like subsurface mining shafts on the ground, and you basically steam and solvents are injected into these underground shafts. So you inject it down into these shafts, all right, and then all of a sudden, liquefied bitumen is pumped up to the surface. So under pressure, it'll be liquefied and it'll come up to the surface. This is the simpler way of extracting it. This other way, here's what they do first. They strip mine. So they cut chunks of the mountain off, kind of like mountaintop removal, right? Then they crush it. They crush all that material, all right, and they put it into a silo. Then they add hot water to it. All right, and the water and the bitumen, they don't mix. The bitumen rises to the surface. All right, then the bitumen is skimmed off and mixed with solvents, things that will dissolve it. Water will not dissolve it because this is a hydrocarbon. It will not. It's a hydrophobic. It will not dissolve in water. So they mix solvents and they dissolve it, and then they process it into synthetic crude oil, basically. All right, and then they have synthetic crude oils piped out. So this method here, over time, has gotten cheaper. So now they're competing with the Saudis and the Venezuelans and the Russians and all the oil they're pumping out of the ground. All right. Oil shale. We're finding a lot more of this in the United States. What is oil shale? Well, it's a bunch of rock filled with this organic matter called kerogen. I remember kerogen. We spoke about it earlier. And then we can process that oil shale, this rock, you can process it into what's called shale oil. Where does this occur? Well, what happened was when kerogen was forming, it didn't get very buried very deep, so it wasn't under great amounts of heat and pressure, so it was never converted fully into oil. So there's a lot of kerogen there mixed with this rock, and you can extract oil from this. All right. How do you extract it? Subsurface or strip mining again. Now, what do they do with it? They take the shale and they bake it. And they bake it in the presence of hydrogen, but no oxygen. If you have oxygen present, could burn or combust in this case. So in the presence of hydrogen with no oxygen on purpose, you don't want oxygen there. You don't want it to burn. And then in the end, these hydrogens get attached and it gets turned into a liquid petroleum. All right. So what they're doing is they're kind of doing a process. You've probably heard the term. They're hydrogenating it, or they're adding hydrogen to it. And by the way, oil sands and oil shale and methane hydrate, these are unconventional versions or forms of fossil fuels. Unconventional as in they've only been around being used recently. It was very expensive to extract them and utilize the oil that they can be turned into. Methane hydrate means that in frozen areas in the Arctic, basically, you have methane trapped between these crystals, these water crystals. So you have methane, that's the gas, CH4, hydrate trapped between water crystals. Now, it's not easy to get your hands on it because it's not so simple to extract it. It's in areas that are very difficult to get into, Arctic areas with a lot of sea ice floating around. I believe only one country, I believe Japan may be the only country that's actually attempted to extract it. There's a lot of potential danger there and havoc. If you release methane into the atmosphere in great amounts and can't harvest it, methane is a global warming or a greenhouse gas. So it will create, methane is a very dangerous gas to be releasing in high quantity to the atmosphere. It could shift weather or climate the same way CO2 does. So what do they do with oils or crude oil when they extract it? They take it and they distill it. So what does that mean? They boil it. And when you boil it, it will start to evaporate. Different things in it will boil off at different temperatures. So it shows you here. And then those things that boil off are collected. And they're collected at different temperatures. And each thing that will boil at a different temperature is then collected in a different area. And then you end up with pure butane or pure naphtha or pure gas or pure kerosene or pure diesel or lubricating oil or fuel oil. So all these are used for different industrial practices. All right. So it starts out as crude oil and it comes out a bunch of different things. Like asphalt, for example, would be made this way too. Fossil fuels, so what do we use then? This is generally and this picture here shows you it all, but here's what happens, and you need to know how an electrical plant works. Right? So generally speaking, what do you start with? You take coal, and this would be an older plant. Most plants today are burning natural gas, but you can burn any fossil fuel. You can burn oil, you can burn natural gas, you can burn coal. So what you do, you break it into small pieces. Right? Why do you break it into small pieces? So it can burn and the reaction will take place faster. Then you heat it up and it starts to burn. And then it starts to boil. That heat starts to boil water. Okay. What happens in that boiled water? It turns into steam. And the steam starts spinning with pressure. That steam starts spinning these turbines. And within this generator are magnets and copper wire. You're spinning magnets around copper wire, and then you generate electricity on the other end. So here's what happens. The coal has chemical energy, and that gets set on fire and gets turned into thermal energy. That's happening right here. Right? Over here, that thermal energy, that heat is causing the water to turn into steam. So it's going from thermal, and movement of the water is increasing, and it's going from steam, thermal, to kinetic movement. Much more movement is taking place in that steam than when it was liquid. All right. Then over here, you're taking that movement of the turbines and you're converting it from kinetic into mechanical energy, which is in turn spinning magnets around copper wire and creating electricity on the other end. Now the electricity can travel through wire and be moved from place to place. All right. So petroleum. Natural gas can be used in this process. Petroleum can be used in this process. Here in the United States, our petroleum is primarily used in our vehicles. All right. And most of you may know this already. Petroleum oil products are used in all the synthetic polymers, the man made materials like nylon and polyester and plastics and things of that nature. Certain materials you wear clothing wise will burn. Certain materials, the ones that are synthetic, made out of petroleum products, those ones will probably melt. They don't catch fire. They'll probably melt. And this picture is showing you all the different products in someone's house that would be made out of potential petroleum products. Almost everything in your house has oil in it, but it wasn't oil, it was petroleum, it was crude oil, and it was converted into something which became a synthetic material used in your house somewhere. What's happening? We're basically depleting fossil fuel reserves. We look at what's called a reserve to production ratio. So how much do we have on reserve versus the production amount? All right. So this is how much is there versus how much we're producing, and it lets us know in how long will we run out. Current estimates say about 53 years, but with technology, they're finding oil and they're finding petroleum and other fossil fuels in different places that they weren't to in the past. So the way we have dealt with the way we have dealt with these reserves and to production ratio is we've just gotten better at extracting it and figuring out cheaper ways of extracting it from now the oil shale and the oil sands and the shale deposits that we have. Hubbard, this was a geologist. He came up with an idea of, hey, listen, in around 1970, we're going to hit a peak and then the numbers are going to start to drop. And that did happen. His prediction was true. But what has happened? All these unconventional sources are now being utilized and our numbers are back up because now we have the oil shales and the oil sands. Methane hydrate, not yet, not quite yet, but the oil shale and the sands are the places we're finding it. Mountaintop removal. This is what they would call strip mining. You just pretty much start out and you start chopping down a mountain, and what you're doing is you're looking for coal seams in there. So there's different seams of where coal deposits are located, where where organisms died and were deposited and buried, partially decomposed. So they do this. They literally destroy the entire landscape. This is one of the worst environmental disasters after mountaintop removal or strip mining in this case. This is just terrible. Severe amounts of rock and erosion. A lot of metallic metals are in these soils and these rocks. They end up in nearby bodies of water. You get a lot of acid drainage. This is just nasty stuff that ends up. It's going to rain. Eventually, you're going to have precipitation. When that happens, it's going to wash away all of this pollution somewhere nearby. And that will conclude our lecture part 2.